question which is asked, which is, if I know that from mechanical property the sum of epsilon I hat and xi hat is equal to 0, why does this imply that the sample correlation between these two variables will also be equal to 0? Okay, so let's try and kind of solve that mystery. The way we're going to solve that mystery is by looking at what is the sample correlation. Well, the sample correlation of epsilon hat x is simply equal to the sample covariance between x and epsilon hat over standard deviation of x, standard deviation of epsilon hat. Okay, so sample standard deviations of those variables. But what is the sample covariance? So let's just take with this term here. Well, the sample covariance is sum of xi minus x bar, epsilon I hat minus epsilon hat bar. Okay, that's what that is. So let's deal with just that top part, because we know that this thing here will have to be positive. Okay, so if the sample correlation has to be 0, this statement here must be implying that the numerator is equal to 0, or that the sample covariance is equal to 0. So question mark, is this equal to 0? Okay. What's the first thing to notice? What do you know about the epsilon I hat? 0 by mechanical property. Okay, it's just the average of the epsilons. So really this term becomes sum xi minus x bar times epsilon I hat. Is this equal to 0? Well, let's open up the brackets and let's use the fact that the summation notation is a linear operator and pull out the x bar because it doesn't have an I or doesn't change. So what do we have? Well, this bit here is by mechanical property equal to 0. So really we have sum of xi epsilon I hat is equal to 0. But this was our mechanical property. So note, this in itself doesn't guarantee, right, that this will happen. You also need, right, you also need the additional, well, the additional mechanical property, which will always hold, that the sum of epsilon I will also be equal to 0. So by having those two things together, you can prove that this mechanical property implies that the sample correlation between epsilon hat and x will also be equal to 0. So if I go back to this question 1, for example, let me go back to this question 1. What you have on the x-axis is the residuals. It's the epsilon hats, okay? What you have on the y-axis is the x's, x1, or in this case, x2, okay? Because of this mechanical property here, we know that the sample correlation between the residuals and the x's must also be equal to 0. Does it look like the correlation between these two variables is equal to 0? No, because that line is not flat, right? So this regression of the wages on log education and log experience is violating the mechanical property, that the correlation between the residuals and education should also be equal to 0. I'll take any further questions.